Good morning, dear students. Welcome to another session of Verilog HDL. So, in previous session, we started off with the discussion related to behavioral modeling. So, in that, we discussed regarding initial and always statements. So, that is the two structured procedures what we uh, looked out. That is, we have always and initial blocks or always and initial statements what we discussed. So the name itself tells that what happens initial, that is this block is executed only once in the entire simulation, whereas always block is executed that is in a looping kind of thing. So it will be executed again and again till the simulation ends. And now again in this you can have multiple initial blocks. Even in always also you can have always initial blocks, multiple always initial blocks. Then you can in initial statement you can have just one single statement. So if there is one single statement, no need of begin and end terms for this thing. So only one statement is identifying one block. But if there are multiple statements to be gathered together in one initial block, then we go ahead with using this keyword, that is begin and end. So these all discussions we had done, and we had seen what would happen if we are not using this delay specification or other things. So even that also we discussed. And in always block also we have the same this thing. So there is one statement in which it is in the always statement. You can have combination and always and initial this thing. So these are the things what we had discussed. Now going ahead, uh, we'll be discussing regarding procedural assignments. So these are assignments are nothing but assigning some values to the variables. So how do you go ahead with those? How do you initialize or specify some values to some variables or some parameters and the other stuff? So here we can see that procedural state assignments, they update the values for register data type, integer data type, real data type, and time variables. So these variables will be assigned some values or the values will be updated. And now in data flow modeling also we dealt with some assignments like continuous assignment, implicit assignments. Okay, so we dealt with these things. How is it? How is this continuous assignment in data flow modeling different from assignments, that is procedural assignments, as compared to in your behavioral modeling level? So what happens is in your continuous assignment statement, that is in data flow modeling, if you remember, what happens is you have one statement specified, say A is equal to B plus C. You have done that. Now what happens in that case is that A value will be changed whenever any one of the parameters, say B or C, changes its value in any of the in entire life of the code. So that is what is happening in data flow modeling. Whereas in procedural assignments, this is not the case. So if I have to specify, right? So suppose I have a statement as A plus B. So the statement is provided in data flow modeling. So let me assume it in this form. So it is present in data flow modeling. Now what happens is initially it is executed, but next time when it has to be executed, next time when A will get a new value, or if I have to specify, when will a new value be assigned to A? This will happen. Uh, this will happen at any moment. Suppose if I do something as B is equal to B plus 1. So what is happening at this moment? B has changed its value. So what will happen? A will automatically get assigned with its new value because there is a change in one of the variable which is allocated in this case. So this is with respect to the data flow modeling. If there is any change in any one of these variable, then there is the estimation done and the variable A is updated. But in case of say procedural statement, what happens is we'll see those also, that if I have specified A is equal to A is equal to B plus C. So here the assignment will be done. And you are writing behavioral level, that is procedural assignments you have done. So when you have done this, if somewhere B gets updated, so A will not be updated in this case. You should have some statement. If you have to update it, you should have a statement specifying A is equal to B or any parameter. If you have another assignment statement, then only A will be updated. So this happens in your procedural assignments related to your behavioral level of modeling. Whereas in the other case, what was happening, if only one statement was present, if there was any change in these variables, right, then that statement was being updated. That is, the variable was updated. But in this case, it will happen only when you have another operator associated with this. If you don't have any assignment operator associated with this parameter, right, then I'll not be updating it again and again. Only when there is another assignment involved, that time only the variable will be updated. So this is what is happening in case of procedural assignments. Continuous assignments, the name itself tells assignments happens continuously. If anything changes with respect to the variables, the assignment will be done to the variable which is dependent on those changed variables. But in case of procedural assignments, it has to follow some specific steps. That is, you assign the values. If any of the variable in that assignment has changed the value, it does not mean that it will go back and assign it unless and until some new assignment is given to that variable. So that will be checking out here. So this is the difference between the two assignments: continuous assignments which are present in data flow, and procedural assignments which are present in your behavioral modeling. So this is the syntax what we follow. So let us look at this one with respect to example. So now just to see what are the values which are possible for this expression is, so you have a left value, which will be a variable to whom the value will be assigned. And this side you can have an expression which is present, or just a term, another variable like A is equal to B or A is equal to A plus B. So those all things are possible. Now here, the left-hand side of this procedural assignment, the left-hand side, that is this part. The left-hand side of the procedural assignment can be any one of these. That is, it can be a register data type, integer data type, real data type, or time register data type variable. Or it can be also associated with the memory element, that is the register what we are specifying. So now here, apart from being these data types, from this data type only, I can have variation. So if I have to assign, say, register data type is of, say, it is, say, vector in its nature, that is, it is more than 1 bit. So in that, only 1 bit I want to assign. So I can do that by bit select operation. That is, I specify, say, here I specified ADDR 0. So what this does is, only the 0th bit of this address or this variable will be updated. Or you can have only a part select of the variable. That is, say, if it is say 32 bits, that is only these bits from 16th to 31st. These bits I want to update. Remaining, I will not be touching them, or I'll not be disturbing them. So even this is possible. That is left hand side. These are the parameters what are possible. Then apart from that, the concatenation of any of the above value, that is these 4 or 5 what we have specified, you can have the concatenation of these also. So we had studied the concatenation operator, which is open brace, comma, and closed brace. So what should be the right hand side? It can be any expression that actually provides you a value. That is, it generates a value. That value will be assigned to the left hand side of this expression, or if this equation what we specify, or the statement. So all the operators what you had studied in your behavioral modeling can be utilized over here. Say the logic operator, relational operator, then say bitwise operators, all those can be utilized over here. Now under these procedural assignments, we have two this thing variations that is called as blocking and non-blocking. So there are two types procedural assignment statements, that is blocking and non-blocking. So let us discuss one by one. That is blocking assignments. So what is actually meant by blocking assignments? So they have something to deal with the sequential type of execution. Sequential execution or assignment is done in some sequential form. So that is what is happening in this case. So here blocking assignment statements, they are executed in the order they are specified. So this itself leads to a sequential execution of those statements. So here, what happens is this statement we'll be discussing later because we have another this thing wherein what is meant by sequential block and what is meant by parallel blocks. So when we come to there, we'll have a discussion regarding this. At present, we'll not bother much about this. So in blocking assignment, what happens is the execution happens in a sequential form. It happens in a sequential form. So what does this imply is, so if you remember in a C programming, what happens is, if you write some equations like if I write something in this form, say int a is equal to 0, then int b is equal to 0 or 10, and some statements we put in. So what happens is after the execution of the first statement, next statement is executed. Now, if you have another parameter over here, right? Then what happens is after A is assigned 0, then you come to C and then you assign C, then you come to the next statement. And so this is how it goes around. That is one by one. So this is actually what is happening in blocking assignment statements. So this is what happens in blocking assignment statements. So here, let us see how do we specify blocking assignments. We actually make use of the equal to operator in order to specify the blocking assignments. So we have examples related to this one. So here we have some port declarations, what they have done. So here we look out with the statements. And since we are dealing with, say, behavioral level of modeling, right? You should either use initial or always, depending on some criteria. Now here you have to put those statements within initial or a block. Now initial block or the always block. Now here you can see that the statements are put in initial block. So if you're getting this, then it is understood that this is behavioral level of modeling. It is following that structure. Now, under that, since you have multiple instructions, you use these two keywords, that is begin and end. So now in this, you can observe that we have x is assigned with 0, y is assigned with 1, z is assigned with 1. Now here what is happening? You are using an equal to operator over here within this initial block. So this is behavioral level of modeling and you are using the assignment. So this is what kind of assignment you are using? The blocking assignment. You're using the blocking assignment. So in this case, what does this imply is once you start off with the simulation, the first this thing which is executed is x is equal to 0, then followed with y is equal to 1, then followed with z is equal to 1. Now here you can see that count is equal to 0, reg A is this one, and reg B and reg A both are initialized to be equal. So that is what you're doing. So here you're not specifying any delays. You're not specifying any delays. So what is happening once this assignment is being done, then only it goes to the next this thing and assignments will be. So, but the simulation starts at time unit 0, at time unit 0. So what is happening is at time unit 0, these all assignments will be happening. But at that time, what happens is first x is assigned with 0, y with 1, z with 1. So on, it will continue up to this point. Now here we can see that we have hash 15. So which is actually delay specification. Hash 15, which is delay specification. And in this one, what we are doing is we are considering one register. In that, we are considering just one bit. That is reg A is how much? Reg A is actually 16 bits. Register A is 16 bits. So in that, only one bit you are considering. That is 0, 1. That is the in terms of index, the second index bit we are considering, and we are assigning it to 1. So this is possible, and this is also what this is a blocking assignment. this is blocking assignment, but you are associating it with the delay of 15. Then after that, we can see that here we have 10. So if we just observe, here we are putting the concatenated result in the selected bits of the register B. We are putting just the selected bits, we are updating the selected bits based on the concatenation result. And lastly, you can see that count is equal to count plus 1. So if I have to see the timing representation for this, so what happens is at time unit 0, these start the execution, but in sequential form, they'll be assigned. X, after that Y, Z, after that Z, and so on up to this point. But even this also starts at time unit t is equal to 0. But what happens is its execution will be at time units 15. After time unit is 15. So at that moment, this will be assigned. So here we can see that all the statements, that is X is equal to 0 through register B equal to A, that is from this point to this point. So as specified, from this point to this point, what happens is they are all executed at time or at time unit when it is equal to 0. But again, sequential this thing will be happening over there. Now here after time, this also will start at that moment, but after 15 time units, it will be assigned with the value. So here where you have, so he hasn't specified. Here he has taken it as 0. Actually, it is updated with 1. It is updated with 1. So it's a typo error. So statement with this one will be executed at time unit 15. Then the next statement, which is updating of just a part of the bits with this concatenation result, that is this part, will be starting 10 time units after this. Because again, if I read it as sequential, so after this, these will be starting, but after time 15, this thing, it will be updating. So here, what will happen? 15 plus 10. So after 25 time units, the execution happens. Now here, I don't have any delay specification, but it is sequential with this one. So after this is executed, this starts off. So what happens is after it is assigned, immediately at time unit 25, this statements get executed and the count gets updated. So this is how the timing goes around. Okay. These are the informations which go around. So here the assignment is happening in sequential form. So in this part, we can observe it much betterly. So after this execution is there, 15 time units, this is updated. After that, plus 10, 25 time units. After that, this starts off, it is just one statement. So one time, this thing, so 25 time units, it will be executed at this moment. So this is what is happening in this case. Now we have another one, that is non-blocking assignments. Non-blocking assignments. So it is why do we require this? That is one important thing. And now previously we saw that assignment is happening in some say sequential form. That is one statement is executed, then it goes ahead and then it assigns. But in non-blocking, what happens is you can schedule the assignments without blocking the executions of the other statements. So that is what is happening in this case. That is non-blocking assignments allow scheduling of the assignments without blocking the execution of the statements that follow in a sequential block. In order to do this, we make use of this operator. Now, if you remember, this is actually a relational operator, but it is actually a kind of overloaded operator. It is a overloaded operator. So what happens is, depending on where it is used, it will be acting as per that. If it is used in non-blocking assignment, it will be operating as a assignment operator. If it is used in relational aspects, it will be used as a relational operator. That is A less than or equal to B. If you're using that, then it will be in a conditional this thing you are using, so it will be operating as a relational operator. But if you're using it in assignment, it will be operating as a assignment operator, which is related to non-blocking assignment. So here now let us see at an example. So what happens how it goes around. So we have non-blocking assignments. So these are the say variables which are declared over here. Again, you have initial. So since we have this initial block, it is behavioral level of modeling. Again, we have begin and end. So this is actually previous this thing itself. These are all previous this thing itself. So okay, so here we can see that we are having combination of both now. Here I have equal to, and here I am having less than equal to. So I can have combination of these also. So it is like this is like sequential execution, but this is like this is blocking assignment. This is non-blocking assignment. Generally, they don't prefer going both in hand in hand. It is preferred that either of them you go ahead. Just for example purpose, they have taken it. So generally, as a developer or a designer, you try to avoid mixing of these assignments. You generally tend to go with only one kind of assignment. Now here we can see that the same example, x is equal to 0 to this point is specified. Then you are using a non-blocking assignment. Here we are using a blocking assignment operator. And here you can see three non-blocking assignments are present. So what happens in this case? So let us just look at the timing details. So here we have in this the statements which are there from x is equal to 0, that is from this point to this point. They are executed sequentially at time when time unit is equal to 0. And after this, there are actually three non-blocking statements or assignments which are present. So what happens is here reg a of 2, which is say equal to 0, what you have specified. Actually, it should be equal to 1. Okay. Here it is scheduled to execute 15 time units later. That is when time is equal to 15. So that is what happens in this case. That is what happens in this case. Now here this statement is executing, but when this statement is executing, since it is a non-blocking statement, it will not block the execution of this statement. It will not block the execution of this statement. It will not block the execution of this statement because these are also non-blocking assignments. These are also non-blocking assignments. So when assignment is going on, when assignment has been done to this using the non-blocking assignment, at the same time, it is not blocking the others from getting updated. Others from getting updated. So here we can see that what is happening at 15 time units, this register A bit gets updated. Now at the same time, this is also actually running around. That is, it is being executed. But what happens is it gets updated after 10 time units. So what is happening? The execution happens after 10 time units. Whereas in previous case, what was the case? What was the thing? It got updated when. So here we can see that after 15 time units, it got updated. But here, if I just observe, since this is a blocking statement, over here, so you have specified delay. This delay has to be associated with the previous one. If you're not specifying delay, all will start the execution at time this thing is equal to 0, and based on that, which one is first encountered. So this will be 0 plus 15. Next one is 10. So from 15 plus this one 10. So there is no delay. It will be starting off. But what is happening, since they have to be updated in sequential form, right? Only after execution of this one, this comes over here. So this is also at 25 time units. This is getting updated. So two things what we have to observe is assignments what have been executed for register B and count. So in blocking this thing, what is happening? Statement reg A gets updated at 15 time units, but next one to be updated, it takes plus 10 time units. So it is after 25 time units, this gets updated. Now here there is no delay specified. So immediately the count is incremented and it gets updated in the count itself. So this happens when this finishes, it comes over here. So at the 25th time unit, even this assignment is done. So this is when blocking assignment is present. Now when non-blocking assignment is present, we can observe what is happening over here. So reg A gets updated 15 time units from the time 0. So it gets updated in 15 time units. But at the same time, it is not blocking anybody else from getting updated because it is a non-blocking assignment. But here what happens is these are all blocking assignments. If you specify delay right over here, like #10, #20, then there will be changes which is happening over here based on the time units when that assignment happens. So now here we have reg only these selected bits which will be updated 10 time units. But this 10 time units, since this is a non-blocking assignment, what happens is from time t is equal to 0, that is time unit equal to 0 up to 10. So at that time unit, that is at when the time unit is 10, that time the register B will be updated. Register B will be updated. Now, when will be the count updated? Now, since this is also non-blocking, this is also non-blocking, what happens is count gets updated at time t is equal to 0 because all start the execution at same moment. So it's a non-blocking statement. So it is not hindering the assignment of the others. Therefore, it is non-blocking. So that is what is happening in this case. So here you can see that at time unit equal to 0, that time without any delay, the count gets updated. So that is what is happening. So this is the difference between the two. Now, you should be careful if you're writing your coding in this form. Generally, this is not preferred. You don't combine blocking and unblocking. That is, you don't combine this and this. These two you try to avoid. Use only one style. Okay. Now, there might be a question as to why such kind of assignments have to be present. That is, say, if you say concurrent kind of execution which is happening. So all start, they get updated. So why should such kind of assignments be present? So what happens in this case is, so before that, if I just specify in this one, if I make this as non-blocking assignments, say these two, x less than 0 and y less than 0. So previously what was happening in blocking assignment, once this is done, then it goes to this part. But in this case, what is happening? You are assigning it using non-blocking. You're assigning it using non-blocking. So what happens is both start their execution, both start their updating the values immediately. So what is the use of non-blocking? Now in majority of the circuits, what happens is you might have seen say a flip-flop and used flip-flops. So you have say input, for example, I'm just taking a simple case over here, and you have a clock associated with this. So what happens is J and K values are available. Say for example, both are 1, 1. And you want to observe the output Q and Q bar. Now, what happens in these cases is, so whenever clock, say, let us assume that it is a positive edge clock. So whenever there is a rising edge, positive rising edge. So at that time, what happens is J is 1, K is 1, both are simultaneously presented to this flip-flop. Simultaneously, they are presented this flip-flop. So J equal to 1 assignment is not hindering K equal to 1's assignment. That is, they are not blocking each other. It is like, it is a kind of non-blocking behavior. And based on that, the assignments for Q and Q bar will be done. Q and Q bar will be obtained. So both will be happening again independently. That is, they'll be non-blocking. They'll be non-blocking. So such kind of behavior we have to model. Such kind of behavior we have to model. So that's why in hardware description language, we have to have these kind of assignments. We have to have non-blocking kind of assignments. So this is one simple example what I have taken. So you can see that if multiple flip-flops are present, what is happening? If synchronous are there, non-synchronous, asynchronous are there, then what are the results? So how I can go ahead with these all things. So that is what we have to look out for. Therefore, we have non-blocking assignments which are present in this case. So one application related to the non-blocking assignments. So what is doing is always when there is a positive edge observed, when there is a positive edge observed. So what happens is you take these registers and assign it. So here, this is a non-blocking assignment, all are non-blocking. So this has to be executed, this has to be executed, this has to be executed. Now there is a problem with this also when you are dealing with coding, right? You should keep even those things in mind. So here what happens is you can see that in 1, in 2, and in 3, and lastly reg 1 is there. So initially what happens is all these parameters will be read. They'll be your code will read it. It will be reading this right side details. That is the right side expressions or variables, whatever you can specify. So that is this side, the right side of the say blocking, non-blocking assignment. So in this case, it is in one, in two, in three. So reg one is there. So these reg one. So all these values will be red. All these values will be red. Now, but what is happening is, since you're specifying delay over here, hash one, but here we are not specifying any delay. What we are specifying is when you see a negative edge, that time you go and assign. So that is what is being mentioned. So first these values are obtained. In short, these values are obtained, and at one go, the values are assigned to the registers. At one go, the values are assigned to the register, since this is a non-blocking. So, but if it was blocking, first this would be executed, then this, then this. So now what happens is, here you can see that he is specifying that the old value of reg1 is used. So what is happening in this case? Since it is non-blocking, all of them start their execution. So initially in1, in2, in3, and reg1 is estimated. But reg1 is getting updated when after one time unit delay. So it is getting updated after one time unit delay. For example, if reg 1 previously was 0, if reg 1 was previously was 0, and new and the value of ion 1 is 1, ion 1 is 1. So what happens is, ion 1 is 1, ion 2 has its value, ion 3 has its value, and reg 1's old value is 0. So after one time unit, this gets assigned, and after one time units, what happens is 0 goes and sits here. It is not the value of 1 which goes and sits in reg 3. It will be 0 which will be updated. That is, it will be using the old value. It will be using the old value. It will not be using the new value. So this is what is happening in this case. So you should be careful when you're using these things. So here we can see what is specified, what all things goes around. So first a read operation is performed on each of these right hand side variables, that is in1, in2, in3, and reg1. And this happens when there is a positive edge seen for the clock. That is when there is a positive edge. So that time you come in and then you execute this. So in this, first thing what it does is it reads all these variables in1, in2, in3, and reg1. And this, if any expression is there, it will be evaluated. So this is an expression XORing which will be happening, and it will be getting the result. And the results will be stored in some temporary, temporary registers, or it will be stored in that form. That is how the simulator will be specifying. So next, what has to happen is, next you have to go for the write operations. Write operations in the sense, you have read these instructions and there is an assignment operator. So this information has to go and sit in these reg 1, 2, and 3 registers. So that is, you should write that information into these registers. So that is what has to be done in this case. Now here we can see that uh, write to register 1 happens actually after one time unit. So new value of register 1 is available. But here I'll not be having the new value, it will be old value which will be considered. So reg 2 at the negative edge will be updated based on this clock. And reg 3 after one time unit will be updated with the old value of reg 1 and not the new value which is being specified. So first the parameters are read and then the assignment happens. So it is like a JK flip-flop what we are specifying. These parameters are first read and then the assignments happen over here. And so, and here we can see that since we are specifying the time delays, it will be executing based on these time delays. So that is what they specify in this. So here the final values of these registers are actually not dependent in the order which they have been executed or assigned. So you should be taking care of these things. So non-blocking is one special case. So it does not depend on where you're specifying what. Reg 2, if you specify first, it does not mean that this will be getting updated first. So what is happening? The right side parameters are read first, and then the assignment is happening. So that is not a problem in this case. So we can see one example which actually generates something called as race conditions. Race conditions. Now here, what is happening is you are considering always block, and you are considering two concurrent of them. That is two separate blocks you are considering. You're considering them in this case. Now, what is happening in these cases is these two actually start off with their execution because both start off at the same time. But what is happening is which one will be assigned first, we are unaware of. Which one will be assigned first, will be unaware of. So this is one disadvantage of your blocking statement. Blocking statement. Whereas unblocking, that is not the case. Whereas here it is creating some problems, but logically it is required. Here if you just see, this is creating some problems, but logically it is required because it has to replicate the behavior of the hardware. Depending on how the simulation works around over in this case, either this always block will be executed or this always block will be executed. Now, similar thing happens even in these two cases also. Whether you're using the thing blocking or non-blocking, what happens is we are unsure which block will be executed. Which block will be executed because slightly earlier this might get executed, that is this statement might get executed, and after that this might go around. And since it is always blocked, right, since it is always blocked, what happens is they'll be continuously executed. Now in this case what happens is when you're using say blocking assignment, when you're using blocking assignment. Now, for example, if you execute this one, what happens is B's value goes and sits in A. Now, after a slight amount of delay, this comes in. This comes in. What is the new value of A? It is actually equal to B. It is actually equal to B. Now here what is happening? B is assigned with the value of A, but A is updated to the value of B itself. So what happens is there will be a time during which both the variables are equal. Both the variables are equal. So here actually what you're trying to do is you're trying to swap the values. I want to swap the values of A and B. That is what they're trying to do here. I want to swap the values of A and B. That is what I have to look around. But if you're using a blocking statement, right, there is a problem that you will not be able to achieve this. Will not be able to achieve this. That is, this might be executed, this might be executed with a slight difference. So if the first one starts off, B's value will be taken and this will be updated in A. Whereas after slight amount of time during the posterior cycle, what would happen is B would be assigned with the value of A, but the value of A is updated to B. So now what happens is both A and B will be having the same values, whereas you have lost the swapping information. So if A was 10 and B was 20, so what would happen is I wanted A's and B's values interchange. That is, I had A and B. This is 10 and this is 20. Now in the first execution, what would happen? B would give its value to A and A would be updated to 20. But after some amount of time, this one starts its execution and it keeps on running. And here what would happen is B might have been assigned with the value of 20 over here. So they'll be ending up having same values after several executions which happen. But how is this race around condition? This is actually called race condition. This is actually called race condition. How is this actually overcome in non-blocking statements? So as I specified, first the right hand side is considered. You read the right hand side expression or the variable in when the operator is non-blocking. When the operator is non-blocking. So whether this is executed or this is executed, first thing what happens is you read the right hand side value. You read the right hand side value and store it in say some temporary variable and store it in temporary variable. So what is happening? B's value is stored in one temporary variable. Say let the B's value be 20 and A's value is 10. So that is being read and stored in temporary variable. This thing. So now what happens is both start their execution. Both start their execution. Now what will be the value of A? A will be using this value, which will be equal to 20. Now what will be the new value of B? B value will be equal to 10. So now what has happened? A and B have interchanged their value. In this case, what was happening? Since A was getting updated, that value was coming over here. But in non-blocking assignments, you will be executing the right-hand side first. Right-hand side values first. So you get to know what are their previous values. You're using their old values. You're using their old values. So B was 20 and A was 10. So once execution starts or assignment happens, B's value will be coming over here, but this new value will not be utilized in this one. So that is what we observed here. This part. That is what we observed here. So in one was there. So we assume that in one was say 1 or 0. Say in one was 1, but old register value was 0. So you have read that information first. So right hand side information is read first and then the assignment happens. So after one time unit delay, in this case, reg 1 is updated. But what is the old value of reg 1? Reg 1 goes and stores in this one. That is the old value. That is what is happening. So you are avoiding race condition. You are avoiding the race condition with the help of non-blocking assignments. Now, there is another question. Can I use the blocking statements to create non-blocking assignments? I can do that with the help of delays. I can do that with the help of delays associated with this. So that is what we can do in these cases. So here processing of non-blocking assignments here specified. So what is happening in this case is, so these are again what? These are blocking assignment statements. So in this case, what is happening? A's value is stored in a temporary variable, B's value is stored in a temporary variable. So both the values are available now in the temporary variables. So before I go further, so now what we are doing is, if I want to swap it, what I'll do is I'll be swapping by using the temporary variables. A is equal to this one and B is equal to this one. So this is how I go ahead. This is how I So this is how I go ahead with this thing. Okay. Using non-blocking, using blocking this thing only, I can achieve this non-blocking behavior. But I have to use these temporary variables in this case, just to swap the two numbers. So this is what is happening in this case. Okay. So this is all for today.